In this part, we will solve some examples on the laws of combinations. Example 5. Find the value of n in each of the following. First, we have nc n minus 2 equals 45. So first, I will simplify the left-hand side. How? We know that if if we have xcy, here it is a combination, it is equal xc x minus y. Okay, also again in another form, if you have ncr, you can write it in this form. N, it is a law, nc n minus r. In numbers, if you have 10 c7, you can write it in another form, 10 c10 minus 7, which equal 10 c3. Okay, so back to the question. Here we have nc n minus 2. I'll use the rules to simplify it. Simplification rule. It is equal nc n minus 2, and it is equal 45. So nc n minus n plus 2 equals 45. So nc n minus n equals 0, nc2 equals 45. But nc2 equals, it's the rule, np2 over factorial 2. Also it is equal 45. So np2 equals 45 multiply factorial 2, and the factorial 2 here equals 2. So np2 equals 45 multiplied 2, which equal 90. Okay, and the 90 we can write it in the form of permutation, equals 10 b2, as 10 b2 equals 10 multiply 9. So here we have 2 and another 2, so n equals 10. Question number 2, example 2, 21 c 4n minus 7 equals 21 c 3n. Now here we have 21 and 21, so 4n minus 7 equals 3n, or 4n minus 7 plus 3n equals 21. It is the rules of combinations. Here, remember it. If NCR equals NCH, so R equals H, or R plus H equals N. NCR equals NCH, so R equals H, or R plus H equals N. It is the same here. We have 21C 4n minus 7 equals 21C 3n. It means 4n minus 7 equals 3n, or 4n minus 7 plus 3n equals 21. One of these 21. Okay, and we complete solution here. 4n minus 7 equals 3. It means 4n minus 3n equals positive 7. So n equals 7. Or 4n plus 3n, it is 7n, equals 21 plus 7. Again, 4n plus 3n equals 7n, equals 21 plus 7. Okay, so 7n equals 28. And now n equals 28 divide 7, which equal 4. So n equals 7 or n equals 4, and we have two solutions. Question number 3 here. NC7 to NC6 equals 4 to 7. Question number 3. We have NC7 to NC6 equals 4 to 7. Now, what is the rule here? I write it here. The ratio rule. NCR over NCR minus 1 equals N minus R plus 1 over R. Again, NCR over NCR minus 1 equals N minus R plus 1 all over R. Here it is the same. We have NC7 over NC6. The difference between them equals 1, like here. R and R minus 1. The difference between them equals 1. Here we have 7 and here we have 6. It is equal. In right hand side it is 4 over 7. Applying this form, this rule, the ratio rule, so NC7 over NC6 equals N minus R. Here N, it is N minus. What is the value of R in this? 7 or 6? No, it is 7. N minus 7 plus 1 over R, which equals 7. Of course, here R is greater than R minus 1 by 1. So we take the greatest value of R. R here, with respect to this example, R equals 7. Here is R and here is R minus 1. So R equals 7. It is equal 4 to 7, which equal 4 over 7. And we simplify it. We get N minus 7 plus 1 equals 4. So N minus 6 equals 4. It means N equals 10. Question number 4. We have NC6 plus NC5 equals 84. So what is the rule? We make this rectangle to write the rule. NCR plus NCR minus 1 equals N plus 1 CR. Okay, NCR plus NCR minus 1 equals N plus 1 CR. Okay, how we use it in numbers? 10 C7 plus 10 C6. Note that the difference between 7 and 6 is 1, equals 10 plus 1, you increase 1 here, C6 plus 1, okay, which equal 11 C7. You will increase 1 in both of 10 and 6. Okay, again NCR plus NCR minus 1 equals N plus 1 CR. With respect to this example, NC6 plus NC5 equals 84. So here's this side will be N plus 1 C5 plus 1. Okay, it is equal 84. Now we have N plus 1 C5 plus 1 equals 84. It means N plus 1 C6 equals 84. And the 84 in the form of combinations equals 9 C6. Now we deduce that N plus 1 equals 9, so N equals 8, and this is the final answer. Example 6, if N plus 1 C3 to N C4 equals 2 to 3, find the value of N. We know that NCR equals factorial N over factorial R multiply factorial N minus R. It is a rule here. So we'll use this rule to solve this problem. Now we have N plus 1 C3. We can write it in the form factorial N plus 1 over factorial 3 multiply factorial N plus 1 minus 3 divide factorial N over factorial 4 multiply factorial N minus 4. Okay, it is equal 2 to 3. Now we simplify this part. Factorial N plus 1 over factorial 3 multiply factorial N1 minus 3, it is negative 2, divide factorial N over factorial 4 multiply factorial N minus 4, which equal 2 to 3. Now we can write this form again. Here factorial N plus 1 over factorial 3 multiply factorial N minus 2 multiply, and we write the reciprocal of this fraction, which equal factorial 4 multiply factorial N minus 4 over factorial N. also it is equal to over 3. We want to simplify the left hand side, so factorial n plus 1, it is n plus 1 multiply factorial n, and the factorial 3 we keep it factorial 3. Here we have factorial n minus 2, it is n minus 2 multiply n minus 3 factorial n minus 4 multiply factorial 4, it is 4 multiply factorial 3. So we have n minus 4 without any change here over factorial n equals 2 over 3. Now factorial n divide factorial n equals 1. Factorial n minus 4 here divide factorial n minus 4 also equals 1. Okay, and we have also factorial 3 divide factorial 3 equals 1. So the rest of the fraction here is n plus 1 over n minus 2 multiply n minus 3 here multiply 4 here in the numerator. So n plus 1 multiply 4, we write it over n minus 2 multiply n minus 3 multiply 1 multiply 1. It is equal 2 over 3. And then we can divide both sides by 2 again. So divide here by 2. We have 1 and we have 4 divided 2 equals 2. Now cross multiplication. We write 3 multiply the numerator here equals 1 multiply this denominator. So we'll get 3 multiply 2, it is 6 multiply n plus 1, which equal 1 multiply n minus 2 multiply n minus 3. So we expand this brackets. 6 multiply n plus 1, it is 6n plus 6, which equal n minus 2 multiply n minus 3, it is n square minus negative 2n plus negative 3n, which equal negative 5n. Negative 2 multiply negative 3, it is 6, positive 6. What that mean? N square minus 5n plus 6 minus 6n here minus 6n minus 6 minus 6 all equal 0. So n square here negative 5n minus 6n, it is negative 11n. 6 minus 6 equals 0. So the final result is n square minus 11n equals 0, and we can take n as a common factor. We will get n square divide n, it is n, minus negative 11n divide n equals negative 11, all equal 0. So n equals 0 or n minus, or here n minus 11 equals 0 implies n equals 11. And this is the final answer. Next question, question number 7. We have two parts here. First part, it is number 1. NCR equals 45 and the factorial n minus 3r equals 24. The required here is to find the value of n and the r. Now NCR equals 45. Okay, and the 45 equals 5 multiply 9. I wanted to write 45 in the form of combination. So I'll make some changes in this in right hand side. So multiplying up and down by 2, we will get 2 multiply 5 multiply 9 over 2. It is the same. Okay, 2 multiply 5 multiply 9, it is 90 divided 2 also equals 45. Now this part, this fraction, it is 90. We can write it in the form 10 multiply 9 over 2. 2, it is 2 multiply 1. So it is equal 10 C2. As 2 multiply 1, it is factorial 2. Okay, so we have NCR equals 10 C2. It means N equals 10 and R equals 2. And we try it here. If it satisfy the other part, factorial n minus 3r equals 24, we will substitute n equals 10. We will get factorial 10 minus 3 multiply 2 here, and you complete, it will be factorial 10 minus 6, it's 4. Factorial 4 equals 4 multiply 3 multiply 2 multiply 1, which equal 24. So n equals 10 and the n equals and r equals 2. It is a solution. Okay, now we will try something else here. When NCR equals 45, we know that 45 equals 10C2. It is equal also here 10C2 equals 10C8. It's from the properties of combinations. 10C2 equals 10C8, as 2 plus 8 equals 10. Okay? Okay, now we will try a solution for n equals 10 and the r equals 8 in this part here. Now again, factorial n minus 3r equals factorial n, we substitute it by 10 minus 3 multiply, instead of r I write 8, equals factorial 10 minus 24, right, equals factorial negative 14. and the negative 14 not equal 24. So n equals 10 and r equals 8, not a solution, because n equals 10 and r equals n not satisfy n factorial n minus 3r equals 24. Okay, so we have only one solution, n equals 10 and r equals 2. Okay, now part 2. We have npr plus 1 divide n cr plus 1 equals 120. And also we have ncr minus 1 plus ncr minus 2 equals 165. Now remember that ncr equals npr over factorial r. Okay, again, if it xcy here, it is also equals xby over factorial y. Okay, I'll use this rule between combination and permutation here to solve this problem. We have here n pr plus 1 divide here. I write ncr plus 1 in the form of permutation. So it will be n pr plus 1 over factorial r plus 1. It is equal 120 equals factorial 5. You can use factorization to put 120 in the form of factorial. 120 divide 1 equals 120, divide 2 equals 60, divide 2 equals 30, divide 3 equals 10, divide 2 equals 5, divide 5 equals 1. So we can write it in the product. 120 equals 5 here, multiply 2 multiply 2, it's 4, multiply 3, multiply 2, multiply 1, it is equal factorial 5. Okay, factorial 5 here. So 120 equals factorial 5. Okay, and also you can use calculator to find it here. 5 factorial equals factorial 5 equals 120. Okay, so n br plus 1 multiply equals factorial r plus 1 over n br plus 1 equals factorial 5. So dividing up and down by npr plus 1, here we have 1, here we have 1. So factorial r plus 1 equals factorial 5. What does that mean? R plus 1 equals 5. So r equals 5 minus 1, which equal 4. Now we wanted to calculate n, okay, from the second part of the question here. So substituting r equals 4, what we get? n c 4 minus 1 is 3 plus n c 4 minus 2 it's 2 equals 165. Now we use the addition rule. nc3 plus nc2 it is equal n plus 1 c3, okay, as ncr plus ncr minus 1 equals n plus 1 cr, okay, equals 165. 165 in the form of combination, it will be 11 c3. So n plus 1 equals 11. It means n equals 11 minus 1, which equal 10. So the solution for this question are here equals 4 and n equals 10. Next question. Question number 8. Find the solution of the equation 2 multiply nc4 minus 3 multiply nc3 plus 2 multiply nc2 equals 0. So we wanted to find the value of n by solving this equation. So here we will use the ratio rule, the rule of division. How? Dividing both sides by nc3. So I'll divide all the equation by nc3. So we have 2 multiply nc4 over nc3 minus 3 multiply nc3 over nc3 plus 2 multiply nc2 over nc3. It is equal 0. We have, what is the rule here? We have ncr over ncr minus 1 equals n minus r plus 1 over r. So I'll use this rule to simplify this part. So 2 multiply ncr over nc3. Here we have r equals 4. Okay, the greatest number between 4 and 3 is 4. So it is equal n minus 4 plus 1 over 4, as r equals 4 in this part. Okay, here nc3 divide nc3 equals 1. So minus 3 multiply 1 plus 2 multiply, here is r equals 3. In this part r equals 3, the greatest one. Okay, so nc2 over nc3 in the denominator, so we will write the reciprocal of this fraction considering r equals 3. So we have here 3 and here is n minus 3 plus 1, all equals 0. Okay, now 2 multiply n minus 3 as negative 4 plus 1 equals negative 3 over 4 minus 3 multiply 1 equals 3 plus 2 multiply 3 over n minus 3 plus 1, it is n minus 2 equals 0. Okay, so here dividing up and down by 2 we get 1 and here we get 2. So n minus 3 over 2 minus 3 plus 6 over n minus 2 equals 0. And I'll put it in another form. So n minus 3 over 2 plus 6 over n minus 2 all equals 3. From left hand side to right hand side we must change the sign. It will be 3. Now how we add these two fractions? We write here, we start from here. Okay, the denominator will be 2 multiply n minus 2. How we write the numerator? By division, by dividing 2 multiply n minus 2 over 2, the result equals n minus 2. So n minus 2 multiply n minus 3, it will be the denominator. Okay, the sign here is plus. I write it plus 2 multiply 6. 2 multiply 6 as 2 multiply n minus 2 divide n minus 2 equals 2 multiply 6. I write it 2 multiply 6. It is equal 3. So n minus 2 multiply n minus 3, n multiply n, it is n power 2. Okay, negative 2n minus 3n, it is negative 5n. Okay, negative 2 multiply negative 3, it is positive 6 plus 2 multiply 6, it is 12 all over 2n minus 4. 2 multiply n equals 2n. 2 multiply negative 2, it is negative 4 all equals 3. Put 3 over 1 here. Okay, and now make the cross multiplication. Okay, cross multiplication. 1 multiply n square, it is n square. Negative 5n multiply 1 equals negative 5n. Okay, 6 multiply 12, it is 18 equals here this denominator multiply by 3. What we get? 2n multiply 3 equals 6n. Negative 4 multiply 3, it is negative 12. Then n square. Okay, minus 11n plus 18 plus 12. 18 plus 12, it is 30. All equals 0. Okay, n square minus 11n plus 30 equals 0. Now we will use factorization. Equals 0. N square equals n multiply n. 30, it is negative 5 multiply negative 6. So n minus 5 equals 0 implies n equals 5, or n minus 6 equals 0. Yes, it means n equals 6. Now we have n equals 5 and n equals 6. So this is the solution for this equation. And of course you can verify these two solutions by substituting in the main equation here, putting n equals 5, putting n equals 5 and check the result. It will be equal 0. Also by putting n equals 6, the result must be equal 0. So we have the two solutions, n equal 5 and n equals 6. Example 9. If NCR equals NCR plus 1 and NCR 2 NCR minus 1 equals 7 to 6, find the value of each of n and r. Okay, so we have two unknowns, n and r. So to solve this problem, we must get two equations. Now remember that rule. When NCR equals NCH, for example, so we deduce that R equals H, or R plus H equals N. Okay, again, when NCR equals here, when NCR equals NCH, so R equals H, it is a solution, or R plus H equals N. Here we have NCR equals NCR plus H. So we have two solutions, R equals R plus 1, and this is impossible. Why? Because it makes R minus R equals 0, 0 equals 1, and this is impossible. Okay, so this solution is refused. Or here we said R plus H equals N, so R plus R plus 1 equals N. So 2R plus 1 equals N. Okay, N equals 1 plus 2R. It is the same, of course. Now we have in the second relation here, second equation, NCR to NCR minus 1 equals 7 to 6. I will write it in the form of a fraction here. NCR over NCR minus 1 equals 7 over 6. We use the ratio rule, ratio between NCR and NCR minus 1. It is equal, the left hand side will be N minus R plus 1 over R equals 7 over 6. Cross multiplication, here we have 6 multiply N minus R plus 1 equals 7 multiply R. 7 multiply R here. So 6 multiply N, it is 6N. Okay, minus 6R plus 6 equals 7R. And 6N or you can say plus 6 equals 13r. 13r. Negative 6r plus 7r, it is 13r. Okay, but we know that here from 1 here, 2r plus 1 equals n. So I'll substitute n to 2r plus 1. So 6 multiply 2r plus 1 plus 6 equals 13r. So we have 6 multiply 2r, it is 12r, plus 6 multiply 1, it is 6, plus 6 equals 13r. So 13r minus 12r equals 12. So 13r minus 12r, it is r equals 12. Now what is the value of n? We will substitute r equals 12 here in this relation between r and n. When r equals 12, so 2 multiply 12 plus 1 equals n. So 2 multiply 12, it's 24, plus 1 equals 25. N equals 25, and r equals 12, and this is the solution.